So hi everybody, my name is John Ferguson and I am CEO of Deepwave Digital. Today I will be talking to you about our company, a little bit about our engineering philosophy, and then our latest product that just came out. Let's see. Here we go. So if you've never heard of Deepwave Digital, we build GPU-enabled software-defined radios. So our software stack, our driver set, seeks to abstract away the complexities of memory movement and data movement around in a heterogeneous computing software-defined radio, so that you can focus on developing your application rather than those types of nuances. So our customers typically use our platform to deploy machine learning algorithms in a software-defined radio at the edge. So when I talk about machine learning and software-defined radio, what am I talking about? Machine learning on what? So we typically break apart the types of data that you can do machine learning on into two categories. There are the internals of the signal and the externals of the signal. So as far as the internals of the signal, we're talking about the actual data that you're trying to transmit from point A to point B over RF. So this could be audio, video, text, anything like that. So when you're doing machine learning in this regime, this is what's more familiar to the rest of the world, right? So doing things like automatic speech recognition, natural language processing. When you're talking about the externals of the signal, outside of this room, it's pretty nuanced, right? So we're talking about applying machine learning actually to the complex valued baseband RF data. So in this world, applications are typically things like spectrum survey, geolocation, modulation recognition, or even adaptive communications. So I bring this up because what we try to do at Deepwave is make it so that it's the same workflow whether you're doing the internals of the signal or the externals of the signal. So our platforms don't care if you're using GNU radio to demodulate a FM broadcast and sending that to an NLP algorithm to get context. It's the exact same workflow if you were to be down converting an RF signal to complex baseband and sending that to an application to do spectrum survey. So this is our latest hardware. This is the AirT Embedded series. It comes in 3 different variants, ranging in capability, and it's powered by the NVIDIA Orin NX modules. So talk about a few specifics of this. So like I said, there are 3 different variants. On the left, we have the Air 7311, which is the most capable higher end variant, and then down to the Air 7301, which is the lower cost, more scalable variant of the new AirT Embedded series. So I'll talk about a few specific feature highlights. So in terms of the software-defined radio, I really like the 7311 because it has 2 transceiver daughter cards. These can be synchronized or they can operate independently. So you can operate in a 4x4 MIMO or direction-finding applications, or you can separate them out and tune them to completely different frequency bands and bring all of that data synchronously down to the same GPU or same machine learning algorithm that you're trying to deploy. All of them have heterogeneous computing, AMD FPGA, ARM CPU, and then of course the NVIDIA GPU modules. And we have put a large amount of data storage on this. So one of the problems that we typically run into is the inability to just store data when you have an edge deployed system. So we put 2 terabytes of data storage on this, or up to 2 terabytes of data storage, which is great for recording baseband data in order to build machine learning data sets for training purposes. And then the feature that I am most excited about is the fact that this is powered by PoE++. So no longer carrying around a power brick to provide 12 volts or 18 volts to your radio. Just plug it into a PoE capable switch and it significantly improves how deployable the system is. So no hardware is complete without a good software stack. So our software stack is called AirStack. You can think of AirStack as the framework that allows the communication between the RF subsystem, the NVIDIA GPU module, and whatever API you want to use to build your application, whether it be PyTorch, TensorFlow, or GNU Radio. So we're managing under the hood the movement of data and the intercommunications between all the different devices on the radio. And then finally, I'll leave you with this. So we like to think of our hardware platforms as a desktop environment in an embedded form factor. That means that we strive really hard to make sure anything that you use on your desktop to do research or to deploy your applications should work on our radios. So if you want to use pip, conda, Docker, any of that stuff, just works out of the box on our platform, and that's to enable you to do the data reduction at the edge. So our hardware is not going to be a platform where you're streaming 16 kilobits per second over an SFP plus or multiple SFP plus ports to a sidecar computer. We put the computing on the radio itself so that you're streaming those data rates directly to the compute module on board, so that what you get off is the answer to whatever your algorithm is doing. So we have a booth over here at the convention hall, and come see us if you want to chat about our hardware. And thank you for your time.